All right, guys, welcome to Math 0106. This is lesson 15. We are going to be talking about fractional notation with decimal notation. So the first thing I'd like to illustrate is that there is a direct way that which they want you to approach this. So let's look at number one. Let's look at number one, 13 over 4. And what they're wanting you to realize is that you can write 13 over 4 as such. Ask yourself, how many times does 4 go into 13? 3 times, because 4 times 3 is 12. Subtract, you get 1. And then we can put 0.0. Bring the 0 down. How many times does 4 go into 10? This is 2 times. Because of the decimal alignment, we have to put a decimal there. This becomes 8. This becomes 2. Carry another 0 down. We get 20. How many times does 4 go into 20? That's 5. And that is 3.25. And that's the traditional way. So all this section is really trying to illustrate is that you can write division problems as a fraction, or you could do long division, which we have previously discussed. Note that if I didn't know that 4 times 3 was 12, I would have just sat off to the side and just kept adding 4 until I would get to a number that's over, and the one right before I go over is how many times I would have to multiply by 4. So we've discussed that before. I'm not going to emphasize that in this video. What I am going to emphasize is that there are other approaches to this. So one thing that I mentioned briefly before, but I think that is worth mentioning again, is that if you subtract 13 minus 4, 13 minus 4 is 9. That means that this is the equivalent of saying 1 in 9/4. And if I do the process again of 9 minus 4, I get 5. That means that I would be adding another 1 to the already 1, which now makes it 2. And so 9 minus 4 is 5. And this would be 2 and 5/4. And if I do this again, I get 3 and 1/4. 5 minus 4 is 1. So I have 3 and 1/4. So this is another way to approach it. If you just subtract the numerator from the denominator and add 1 to the previous, the number in front, you can slowly convert yourself to a mixed number that is where the fraction is in reduced. Remember, reduced just means the denominator is greater than the numerator. Okay, so you have 3 1/4. So how does that help me? Well, we know that this is 3.25. This one is chalked up to be a pretty simple situation because we know 1/4 is a quarter is 25 cents. So that's easy enough, doesn't require too much more than thinking about it in that sense. But we may come across fractions that are a little bit more complicated than this. And so one thing that I'm going to do this on a separate page. One thing that I always tell students, at some point in the course, I always tell them to, I think it's always a good idea, is to just simply memorize these. And the reason why is they're so frequent, they pop up so often that you might as well have them in your head. And the other thing that's really nice about this is that it's actually pretty easy to memorize these. There's nothing particularly complicated about this. So you know 1/2 is 0.5 as a decimal, or 0.50, because you know half a dollar is 50 cents. 1/3 is commonly known as 0.333. I think most students know that. Most of us know what a quarter is, 0.25. 1/5 might be a little difficult, but I hear that a minimum tip should be 20%, which is dividing the bill by 5. I'm not sure if that helps. 1/6 is 0.166, and I think that this is easy to memorize because you have literally a 1 and a 6. 1/7 is approximately 0.14. I just think 7 times 2 is 14. 1/8 is half of 1/4, and half of 25 is 12.5, so this is 0.125. 1/9 is 0.1's repeating. And this is easy to remember because you know 3/9 reduces to 1/3, which is 0.333. So if 3/9 is really just 1/9 times 3, right? Then this makes sense to this to be 0.11 because that times 3 is 0.3333 repeating. So there's a thought. 1/10 is 0.01. I used to not say this, but it's so easy to do 1 over 11. It's just 0.0909 repeating that I include that now as well. And the reason why I'm saying to memorize these is that if it's first, it's not difficult to. Most of these you probably already know or you could quickly decipher or use these little mnemonics that I showed you to memorize it. But if you have these memorized, I use the example of 3/9 to show that I can easily convert 3/9 to realizing it's 0.333. So let me give you another example. If I gave you, let's say I gave you 4/5. Well, if I know 1/5 is 0.2, then all I have to do is multiply that by 4, and 4/5 would be 0.8 or 0.80. And it's as easy as that. And you can work through all of these in a similar pattern. So these occur so often that it's might as well have it in your head. And when you see the situation emerge, you just, hey, I just multiply by 4 if it's 4/5. If it's 3/5, I'm just going to do 0.2 times 3 because I know 1/5 is 0.2, so times 3 is 0.6. So it's 0.60 or 0.6, and so on and so forth. And so I think that makes your life way easier if you start to memorize those. But going back to this, so that's the exercise we're more or less entailed with here. So let's approach the next one, number 2. And what I'm going to do here is I'm going to approach it with what I think is the most appropriate means towards solving it. So if long division is the most appropriate, I'm going to use long division. If I can use something that I've memorized previously to solve it, I'll go ahead and do that. So number 2 is 3/10, and I'm sorry, 3 over 20. And I didn't put 20s on the list, but earlier in the course, I did mention on a problem that we know that if you take a test, if you have 20 questions on a test, we know that each one is worth 0.05. And so that means that 3 over 20 is just 3.05, so that's going to be 0.15. Another way you could do this if you really wanted to, if you wanted to be slick, you could say, I know that 3 over 20, if I divide both of these by 2, 3 over 2 is just 1.5. Just think if you have $3, you cut it in half. I'll get 1.5 over 10. And earlier we've said what the rule is with when you have a 0, you just move the decimal place over and you get 0.15. So that's another way of solving it. And what you're seeing here is that what I'm doing is I'm using a lot of the rules we've talked about before to solve these current problems. And that's perfectly fine. Hopefully, if you get overwhelmed, remember, if you're completely overwhelmed with all of this, you don't need to be, just do long division. So let me do this one via long division just to curb any sort of anxiety someone would be facing with they not for certain on how to approach this. So this would be 3, this would be 20. Because 20 doesn't go into 3, we're going to put a 0 here, and that means we're going to have 1, because 20 goes into 30 one time. 1 times 20 is 20, subtract, we get 10. Bring another 0 down. How many times does 20 go into 100? 5 times, so that's 0.15. And if that's how you're looking at it, you're like, Mr. Anderson, please, I just want to do it that way. Is that okay? Yes, that's perfectly fine. I just find learning these other ways and thinking about it creatively enables you really to solve these problems with minimal amount of effort. And that's why I like that. But you can always resort back to these other methods as well. Okay, so let's go on to the next one, 11 over 40. Now, 11 over 40, there's no easy trick with this one. We're just going to have to blunt force it. So we're going to have to do 11 goes into 40. By the way, the previous long divisions, they've been very simple, so I've just been solving it. But if you need to list to the side of adding the numbers together because you don't know what the multiples are, that's perfectly fine as well. And I bring that up here because obviously 40 doesn't go into 11, so now I have to add a decimal. I'm going to put 0.0. And now how many times does 40 go into 110? So I'm going to just keep adding 40 here. And some of you may be like, Mr. Anderson, come on. I know that this goes in 2 times because 3 times 4 is 12. And if you see that, fantastic. I'm just going to list it because I want to be as clear as possible for those who don't see it. So it'll go at 3, we go bust. We've gone over 110, so it's only going to be 2 times. So we know that this is going to be 2 times 40 is 80. We're going to subtract, and this gives me 30. I'm going to include a 0. It's going to become 300. So how many times does 40 go into 300? I don't know, so I'm just going to keep adding 40s. So this is 160, 200. Old work. Need to get rid of that. Let's see, do I have anything up? That's it. What do I add? 200 plus another 40, 240, another 40, 280, and I think I'm actually, nope, I had more work, which is good because I need more space. So now if I subtract, add this, we get 320, and we've gone broke. Okay, so this, we were at 3, this is gonna be 4, I gotta put it on this side because I'm too close to the edge. 5 times, 6 times, 7 times, and the 8th time I've gone over, so it's 7 times. So now we know that this, let me do a different color. This is going to be 7 times. 7 times 40 is 280. We're going to subtract and we get 20. So I include another 0. This is getting very, very cluttered. I apologize. And we're going to do it again. So we're going to see how many times does 40 go into 200. Well, we know that this is going to be 5 times. And because of the interest of space, I'm going to stop there. So it's 0.275. So sometimes the only approach is long division. And when that's the case, you just do long division. Now, in number 4, we're going back to some of the rules we've talked about before. So we know when we divide by 10, we know we're dividing, which means we're making the number smaller. So if the number is becoming smaller, it makes sense that we would move the decimal place to the left to create 10.3. And again, all I ask is that when you approach questions like this, if you're not for certain, just ask yourself what makes sense, right? And number 5, 1/4, we've seen this multiple times. Hopefully you know that this is now 0.25. I mean, we did it earlier with number 1. Now with number 6, 3/24 reduces to 1/8 because they're both divisible by 3. Now 1/8 is obviously not the answer because we can rewrite this as a, I'm going to rewrite this as a decimal. But earlier, remember I told you to memorize 1/8, which is 0.125. So this is just 0.125. And if you notice that if you took 1/4 and you divided by 2, which is the same thing as multiplying by a half, you would be getting 1/8, which means if I multiply 25 or cut 25 in half, I would get 0.125. And by the way, cutting 25 in half is not very difficult because 25 is the same thing as 24 plus 1. So if I divide both of these by 2, I get 12 plus a half, which is 12.5. So little overkill, but a good illustration of how to use a lot of these things that we've talked about throughout this course in order to solve these problems efficiently and effectively. So I hope that makes sense. Let's move on now to number 7, 2/3. Now remember, I said earlier back here, 1/3 is 0.333. So if I have 2 of them, this is now 0.666, repeating. The line on top just means we keep going. So again, you can see that if you've memorized some of these, this becomes very, very easy. It's very simple exercise. So 3/11, well, again, we look back here and we see 1/11 is 0.0909, which is just multiplying by 9. So 3 times 9 is 27. So this is just 0.2727. Easy enough. Going on to the next one, we have 8/15. Now, I haven't written my list out to 15, so the appropriate measure to this one is to just do long division. Hence, you can see me erasing, because we know whenever we do long division, we need lots of space. But let's do that. So 8/15. Now, the most important thing is to realize that the 8 goes inside, so the 8 is the dividend, whereas 15 is the divisor, the one doing the dividing. One way to remember this is think of this as like a person on top of a horse. So the person goes inside the house while the horse, which is on the bottom, goes outside. So hopefully that makes sense. Or if you were struggling to keep that straight in your head, that helps you out. When I look at this, obviously 15 does not go into 8 evenly, so I add a 0. So now I'm considering how many times does 15 go into 80. Again, if you know how many times off the top of your head, you can just simply write that number down. I'm going to list because I feel that many of you would prefer that. Let me put it that way. And I have to erase some more. Okay, and let me erase some more. Okay, so welcome to Anderson's videos, where half the time you just listen to him saying he's erasing. Okay, but in any case, we can see that this works how many times? We have 1, we have 2, we have 3, we have 4, which by the way makes sense because a clock is 60 minutes, so it has 4 15-minutes in it. This is 5, and then we go bust at 6. So remember, we go bust at 6, so we have to use 5. 5 times 15, we have that here already, it's 75. We subtract, we get 5. This becomes 10, 5. This would be 7, 0. So we add another 0, we go 50. And again, the nice thing about this is if you do it this way, if you don't have things memorized, well, you know 15 goes into 50 4 times, because 5 times you go bust at 75, so it has to be 4 times, which then tells me that this has to be, I lied, not 4 times, 3 times. Sorry, I was thinking 2 things at once, because at 4 we go over, we're at 60, so we want to use 3, which is 45. Hope that makes sense, right? 45 is under 50, whereas 60 would be above, so I can't use 4, I have to use less. And this is going to give me 45. We're going to subtract, and we're going to get 50. And so you see that there's a pattern here that's very interesting, because if I do this again, it's going to be 3 times, and I'm going to get a 45 again. And if I subtract, I'm going to get another 50, and you'll just keep getting 50. So this is just simply 5.3333 repeating. So 8 over 15 is just 0.5333 repeating. Okay, now what about number 10? Well, let me do what I always do in these videos. Let me erase this, so I have a little bit more space. And in number 10, my advice is first get rid, let me just write it out, 15 over 11. Let's get rid of the improper, let's make it a mixed number. So 15 minus 11 is 4, so we know that this is 1 and 4 11ths. Now recall that 1 over 11 is 0.0909 repeating, so 4 times 9 is 0.36, so this is 1.36 repeating. And again, if you don't like that, you can always do long division. Okay, 5 over 6 is, well, we know 1 over 6 is 0.166 repeating. 5 over 6, if 1 over 6 is 0.166 repeating, we would just have to multiply 1 over 6 by 5, so 0.16 is 0.16 repeating. So we're going to multiply that by 5, 33, 8. So you're really going to end up getting 0.833 repeating because of the approximation. You have the 0 here, but essentially what happens is the 3 becomes repeating, so it's 0.8333 repeating. Again, if you prefer, you can always do this via you can just do long division, you'll get the answer. Number 12, 8 over 7. Again, if you subtract 1, you get 1 and 1/7. We said that 1/7 is approximately 0.14, so this is 1.14 approximately. Now the question, if it asks for specifically, you'd have to work it out long division. I'm not too concerned with that. Most of the time, the problems that are cooked up are pretty straightforward, so 1.14 is sufficient for me. Okay, so moving right along, let's look at number 13. Now 13 is interesting because we're doing what we did before, but now we're going to round. So it's asking us what is 8 over 15, and if you recall in number 9 we did 8 over 15 and we saw that it was 0.533 repeating. So if it says thousandth place, remember we said this is tenth, this is hundredth, this is thousandth, so all I'm going to have to do is erase that. And because remember it's 3 or less, we keep it as is. 4 or less, we keep it as is. 5 or more, we round up. We leave 0.533 as the final answer. Okay, let's move on to number 14, and it's doing 13 over 11. Again, if we subtract 13 minus 11, we get 1, so this is 1 and 2/11ths. We know 1/11 is 0.09, so this is 0.1818, and it's saying round to the nearest tenth, so that we see this is 8, so this is 0.12. I'm sorry, tenth. Here I am not thinking. Not 0.12, it's 1.2. What I'm doing right now is I'm thinking so far in advance that I'm forgetting where I currently am. Okay, the mind works faster than the hand. Let me put it that way. My mind is going at a faster rate than my mouth can say things. Okay, so 3/7. Well, we know 1/7. Again, 1/7 is 0.14 approximately. So if I multiply that by 3, I get 0.42. And so it's saying round to the nearest hundredth. It's 0.42. The one thing I will say here is, remember, 3/7 is approximately. So if you actually did it, like worked it out, you would have gotten it to be 0.42857, and then it repeats. So if we round to the nearest hundredth, we get 0.43. I think it's a little bit in excess to write out the remainder all the way out to that degree. I mean, we could do it, but I think it's a little excess. But let me do this. Let me just do this one to show you what it would look like. You don't need to do this. I think overall, most of the scenarios that you would encounter would require you want to have something to this degree. And if you were rounding, then it would make sense. You're close enough if you just do to 2 decimal places in most situations. But in case we have to be precise, let's be precise. So if we have to be precise, I recommend doing long division. So I have to add a 0. We see a 7 goes into 30. Now, interest of time, I know that 4 times 7 is 28 and 5 times 7 is 35, so I'm not going to concern myself. If you don't know that, that's just telling you, hey, you got to practice those multiplication tables. I get 20. We're going to have a long way of writing this out. 7 goes into 22 times, so we're at that 0.42 that I mentioned earlier. 7 times 2 is 14. This gives me 6. Bring another 0 down, so we're at 60. 8 times 7 is 56. Couple of I said 8 times 7, and it should be 8. A couple of ways of remembering that 8 times 7 is 56. The coolest way I've ever seen, somebody told me this, and I thought, this is amazing. If you can count 5, 6, 7, 8, so 7 times 8 is 56. Easy way to remember it. Someone told me years ago this, and I thought it was kind of cute. Mido and Fido can do tricks. 8 times 7 is 56. You can do that as well. But I think remembering 5, 6, 7, 8, 8 times 7 is 56 is pretty easy. There you go. In any case, you get 56. So we'll subtract, we get 4, bring another 0 down. I think, hold on, let's see here. Yeah, I'm still aligned. So 40, 7 goes into 45 times because that's 35. 6 times would be 42. So we're going to do 35 here, subtracting at 5. We're going to have to add another 0. Then we're at 50. 7 goes into 8. That'll be 7 times, and we're going to get 49. Bring another 0, and that's going to be 1 time. 1 times 7 is 7, and we get 3. So we're back. So you can see now we're back at 30, and the process would repeat. So this number is going to be 428571 technically. That was the number I showed you earlier. If we're rounding to the hundredth, remember hundredth is the second decimal place. The first is tenth, and hundredth, and thousandth. So this would become 0.43. So the exact answer is 0.43. Again, I said 0.42 because I had just rounded it originally to 0.14 for 1/7. So there you have it. Yes, it can get pretty nasty. But interest of time, let's just, well, how about this? Look, 12/7, we know 12/7 is, if we subtract 1, we get 1. 12 minus 7 is 5. 1 5/7. So again, I'm going to say it's sufficient. If we're doing 7, it's sufficient to say that 7 is approximately 0.14. And if 7 is approximately 0.14, 0.14 times 5 is 70. So this is roughly 1.7. 5 over 7 is technically 0.71, 4, 2, 8, 5, and then it repeats again. So this, if actually I was rounding this digit would have to be a 6, but it basically repeats this combination over and over again. So the true rounding, well, what are we saying? 10,000th? I said 0.170 because I was rounding to the 100th. But if I was going to round to the 10,000ths, this is the 10th, this is the 100th, this is the 1,000th, this is the 10,000th. So the answer would be 7143. And that would be the precise answer. So if you wanted to, you could do it via long division. I think this is a little bit excessive in terms of practicing. You don't need to really concern yourself too much with that. But if you wanted to, you could practice it and see if you get 1.7143. And if you really want me to work it out, ask, and in the next video, I will definitely do that. Okay, so that is pretty much it. Hopefully that makes sense. I know there's a couple of problems at the end of this page. I'm going to save that for another video. All right, so any questions, comments, email me or post in the comments, and I will try to get back to you as soon as possible. All right, guys, hopefully this works out well, and I will see you guys in the next video.